Hello and welcome to the 1059 Agricultural Internet of Things device project. The sponsor for this project was Dr. Flora Seabido, who does research for the Lake Erie Regional Grapes Research and Extension Center that Penn State owns. Dr. Flora tasked us with building an IoT device that would get measurements from the field's grape crops without needing to go out onto the field and gather them manually. Further specifications were that the system consume the least amount of power possible, that it be able to gather soil pH, moisture, and temperature data and send it to an on-site computer every hour, and that it also presents said data in an easy-to-read format on an on-site computer. In order to achieve the aforementioned specifications, we decided to employ an Arduino Nano and a Raspberry Pi as the main technologies for our system. The Arduino Nano has a required amount of I/O pins for the sensors that are being used, and also employs the 18 Mega 328P, which is a low power consumption microcontroller. The three sensors that are being used are the tidal pH sensor, which was chosen due to its lower cost, the SparkFun soil moisture sensor, which was chosen due to its lower cost and power consumption, and the Voltage Labs ground temperature sensor, which was chosen due to its lower cost as well as its lower power consumption. All of the sensors listed were also chosen due to their synchronicity with their Arduino Nano. The Arduino program is set to run every hour and capture the readings of all three sensors, as well as send them to the Raspberry Pi using the transmitter and receiver Radiox LoRa modules that were employed for this project. Using a web server that was built into the Raspberry Pi, the data is compiled and shown on three separate graphs that show the respective data. These are itemized by date and timestamps. Once the user has gathered enough information or they want to get new data to show on the graphs, they can simply click on the refresh button to get fresh data. After the system was deemed by the team members to be fully functional, the real power consumptions for all components were tested and a battery was obtained. The battery is a Z-LiPo battery that is usually employed in RC devices. Due to the proof of concept nature of this project, the battery is only set to keep the system working for 6 days maximum. This will later probably be changed by the sponsor. For the purposes of this demonstration, the timer on the program is set to 10-second readings. This has been the senior design presentation for the agricultural IoT device system. Thank you for watching our demonstration.